a PN junction, or you can say a diode, they have a lot of uses, like practically speaking. The electronic device what you are seeing through, they all use diodes, but different types of diodes. Okay, so every diode has its own application and its own structure. Now what we are doing is we are using a very simple example, or you can say a simple practical use of a PN junction. Okay, these are what we call as rectifiers. Okay, now a rectifier is the sense what? It is a device which converts alternating current or voltage, AC into DC, direct current or direct voltage. This is what we mean by a rectifier. And this process, this phenomenon which happens, this is what we call as rectification. Alright. Now, rectifiers are used in many cases. Okay, in a lot of cases we use rectifiers. Like couple of chargers, they have rectifiers. Okay, and you have this voltage regulators, there we have rectifiers. So, rectifiers are used in many cases. Alright, let's try to understand what is it. Now, in rectifier, you have an alternating current. That rectifier will convert it into direct current. Now, we have two types of rectifiers, half wave rectifier, full wave rectifier. Okay, now when we talk about half wave rectifier, what exactly happens here? Let's try to understand. Look at this particular figure. Now, in this, what do we see? You have one PN junction. You have a transformer, correct? Remember one thing, transformer will work only and only on AC, not on DC. So what we do, we have a transformer, we have two primary coils and we have two secondary, see P1, P2 and S1 and S2. Now the secondary is connected to a PN junction, a diode. Alright. Now the output what we take is through the resistor, whatever we have. Fine. Now what happens? First, in the first half of the cycle, you have an alternating cycle, correct? You have an alternating current. First half of the cycle, the positive half of the cycle, the P-type of the semiconductor is going to become positive. That means N-type will become negative. This is forward bias condition. And in forward bias, what happens? The resistance is very low. Correct? Current passes through it. Happily, current will pass through it. But in the other half of the cycle, what happens? The PN junction will become reverse biased because P-type is connected to negative. If it's in a reverse bias condition, then resistance is going to become very high. So no current passes through the load resistance. Fair enough? So under the first half of the cycle, the positive half of the cycle, current was passing through the diode or the PN junction. And in the negative half of the cycle, there was no current at all. Isn't it? If we plot the input and output, look at this particular graph. This is the graph what we are going to get. See input, how continuous, peaceful it is. And look at the output. Now, what exactly we call this output as? See, this particular output, first, it is pulsating. Like, see, you get, you don't, you get, you don't. It's pulsating. Isn't it? Up and down, up and down, up and down, up and down. It's pulsating. Second one, after pulsating, we have intermittent. Comes and goes, comes and goes, comes and goes, intermittent. Third one, what we have is the unidirectional. It goes in one direction, no? That means the current what we get is pulsating, intermittent, unidirectional DC. Okay, this is the first observation what we can do with the help of this graph also. Second observation, which is very important, is the efficiency. Single diode, just one diode we are using, correct? So the half wave rectifier is going to have very less efficiency, around 40%, you will have 40, maximum 41. It's between 40 and 41. So when you have 40% efficiency, it's not a very good device or an instrument. The next observation what we have is that, see, any wave, they have frequency, correct? The frequency of the output is the same as the frequency of the input. Okay, so this is another observation what we can do. Clear with this? Now this device is what we call as half wave rectifier. So in the next one we'll look into full wave rectifier.